Yeah, welcome back. Another class on the introduction of the engineering mechanics. Okay, so in the previous classes, we have discussed about the what are the different types of forces and how the forces can be act on the material, and you are going to calculate the what are the displacements and what are the resultant using the different theories, right? So here we have the two questions, one, and this is a second question. Okay, so I just request you to let us understand the problem first, because once you understand the problem, you can solve n number of problems related to such type of okay. So here in the question, it is determine the magnitude and the direction of the resultant. So what is that? You need to calculate the magnitude, means the weight or the forces quantity that you have to calculate. Magnitude is nothing but how much the force is applied to the particular body or the particular element, that is called as the magnitude or the weight of the body or the quantity. And again, you need to calculate the direction of the resultant. So what you have to calculate? You have to calculate the resultant. Let us say R is the resultant. For that, you need to calculate the magnitude of the resultant, and also let us calculate the direction of the resultant. Of the two forces, how many forces are applying? There are two forces are applying. One is 100 Newton and another is 150 Newton. It means that there is a one object, in that there are two forces are acting. So two forces are acting at an angle of 45 degree. There is an angle is mentioned between these two forces, that is 100 and 150, and the angle between these two forces is an 45 degree. Let us draw an angle is 40, the Newton, right? Resultant of these two forces. Let us say this is the resultant. Let us assume the resultant may be here. Okay. So when the two forces are applying at an angle between the two forces, that is 45 degree, then using the parallelogram theorem, okay, when two forces applying, so we can construct a parallelogram theorem. So what is the angle between these two forces? That is 45 degree, and the force 1 is 100 and force 2 is 150 Newton is applied. Let us construct the parallelogram. So now it becomes a parallelogram. Now in the diagonal there will be an resultant forces. So this is an resultant forces. Is it clear? We have constructed the problem into a parallelogram theorem. When we are having the two forces at a certain angle, then we can apply or we can go through the resultant forces. In the question, it is not clearly mentioned by which method you have to calculate the resultant. But whenever there are two forces and the angle between the two forces, then you can go for the parallelogram theorem. Like I have constructed the parallelogram. Two forces at an angle of 45 degree. Let us this dot line to be represent the parallelogram and the resultant at the diagonal. Now we can apply the parallelogram. So in the parallelogram, the resultant R is equal to, it is under root of P square plus Q square plus 2PQ cos theta. Now let us explain you what is P. So P is the force acting in one direction, and Q is the another force is acting, and where theta is the angle between these two forces. Like let us say this is P and this is Q. You can denote any one, you can represent P or Q, and the angle between these two we can represent theta. Hope it is clear to you. The board, it may be visible. If you are there is a problem of quality, then you can change the resolution so that you will get the clear visibility. Okay. Now let us substitute. What is the value of P here? That is 100 square plus value of q, that is 150 square, plus 2 into p is again 100 and q is 150 into cos theta. That's what is the value of theta again? It is 45 degree. Now you will get the value of resultant forces. Okay, anyhow that calculator is not with me. Sorry, I will wait for some time. Okay, right. Okay, so now we will calculate the value of the resultant forces. I will substitute under root of 100 square plus 150 square plus 2 p cube into cos theta degree, that is. Okay, so make 100 square plus 150 square plus 2 into 100 into 150 into cos 45 degree. Now whatever the value you will get under root of the answer, then you will get 231.76. so resultant, this is also the force, the resultant force. So you will get the resultant of 231. Okay, so this value is, the resultant value is 231.7 Newton. Now you have calculated the magnitude of the resultant. Now you need to calculate the direction, at what direction the resultant force is applying. In the initially we assume that it is at the diagonal. Okay, now we will say with the magnitude we can calculate where in the HS it is tan alpha. So you need to calculate alpha plus 150 cos 45 degree, then you got 0.51, this value 0.51, then we'll make where alpha is equal to tan inverse of 0.51. Okay, so again tan inverse of the answer, you will get 27.23 degree. 27.23 degree means the resultant is acting at an angle of 27 degree. Resultant. Okay, so my intention is whenever the two forces are acting, or the number of the resultant. Okay, when you are having the two forces with an angle between these two forces, then we can apply parallelogram. So whenever in the important problem or important basic problem where you can find the resultant forces, means number of forces are acting there. So the problem may be asked in different ways. Sometimes they can diagram or the figure, and in many practical application you have to find out these forces. So this I have drawn here. Before that there is a question. Okay, so this is an, after the question I have made this construction, but in the question it was mentioned that there is a force of 20, please listen, there is a force of 20 Newton, it is acting at an angle of 30 degree in this is an east west, and here it is given as north south. Okay, so in a direction they have mentioned the problem, and you have to draw this free body diagram so that you can easily understand about the direction of the points here. So the question, first one, it is given as 20 Newton is applied at an angle of 30 degree in east and north. East and north. East and north direction. How much? 20 Newton is applied. There are two forces are acting. So we have. Okay, I am facing some disconnectivity problem. I don't know the reason. Okay, maybe some network issue today. It is getting automatically disconnected. Okay, so maybe another 1-2 hours the same video will be uploaded, so you can watch in the channel also, right? So next problem I will solve where 35, if you resolve horizontally, then again 35 is towards the left, minus 35 cos 40 degree. Okay, now let us calculate the sum of horizontal forces. Okay, so I will tell 20 cos 30 degree minus 30 cos 45 degree minus 35 cos 40 degree. Then I obtain minus 30.7 Newton. This also force. Now let us calculate the vertical. So similarly you have to write resolving all the forces vertically. You have to resolve all the forces vertically. So when you resolving all the forces vertically, so how many forces? Again 4. So this force you have to resolve vertically. So 20 resolve vertically. So 20 resolving, the direction is towards upside. Okay, so what will be the direction here? It is up. Okay, so up is plus 20 sine angle is 30 degree. Another force 25, it is apply vertically, so we can directly write plus 25. Okay, no inclination. Another 30, if you resolve vertically, so this force vertical direction is towards up, so plus 30 sine 45 degree. Another force 40, if you resolve vertically to this vertical line, so the direction of the force is down, so it is minus 35 sine angle is 40 degree. Now let us calculate 20 sine 30 degree plus 25 plus 30 sine minus 35 sine 40 degree. So I obtain 33.7 Newton when you resolve vertically. Okay, so horizontal and vertical we have calculated. Now substitute these two in the resultant, where r is equal to under root of minus 30.7 whole square plus 33.7 whole square. So 30.7 whole square plus 33.7 whole square. Under root of the answer you will get 45.58 Newton. So this is the magnitude of the resultant. Now let us calculate what will be the angle theta. Okay, so where theta is equal to, there is an equation, tan theta is equal to sum of vertical force divided by 7 and h is minus 30.7. So minus also you have to consider because there is a difference in the sign also. 33.7 divided by 30.7 of tan inverse of the answer. So we got minus 47.7 degree. Okay, so it indicates that there is a horizontal force in negative, it is negative, and the vertical force it is positive. So horizontal is negative, so horizontal negates, always it will be in the left side, it will be right side in the positive, and upside positive, downward is negative. So now you got horizontal as negative, it means the resultant is towards in the somewhere in this quadrant, and vertical one is positive, it means this the resultant force is lies somewhere here. this is the resultant. R value is how much? 44.58. 45.58 is acting at an angle of 47.7. So 47.7 is nothing but what will be the angle here? Okay. So in the second quadrant, 47, anyhow this angle is not available, so we can calculate where theta is equal to 180 degree minus this one 47.7. So we will get 180 minus 47. So 132 at an angle of 132.3 there is an theta, means from 0 to here 132.3 degree at an angle of this. So anyhow here it will be again 47.7. This angle is 47.7, remaining angle. Okay, so in that point the resultant is lies in the second quadrant at an angle of 47.7, and the magnitude it will be 45.58. Okay, so hope this problem you understood, and this is the one of the most important, because whenever you are doing any problems, this concept it will be applied, and it is the most important in the engineering mechanics to understand how you are solving by horizontal and how you are resolving by vertically, and calculating the resultant and the angle for the resultant is most important in the examination. Okay, now you can go through the different textbook and apply the same concept, and let us calculate the resultant, so that you will get your confidence level in the solving problems and practical problems, so that you can apply how the force is acting. Sometimes these are all tensile forces, sometimes there will be an compression forces also. Okay, these are all what we call, it is a concurrent coplanar forces. Right, okay, thank you who are all online. Now you can post your attendance roll number, so that I will consider. Okay, so if possible take the screenshot of your roll number, then you can send to me personally. Thank you one and all. Okay, if you have having any doubts also, you can ask me. Let us take another 5 minutes. Yes, hello Vishnu, Mohan, Rajesh, Dega, Tiru, Deepu, Omshar. Yeah, many of them came today. So okay, so hope you are all little interested in. Okay, 309. Right. So any discussion? If you started solving the problems now, you will the doubts, so that you can discuss with me. Because the maybe shortly you will get the announcement for your mid one. Yeah, please post roll number. And some of anyone can take the screenshot of this, because no, I am it is in the landscape mode now. I cannot take screenshot for all the numbers. So anyone come forward to take the screenshot and send me through my WhatsApp number. Yes, any doubts for the today class? Okay, then I will close. I hope everyone posted your details. Then I will quit now. Okay, so we will meet another time. during my because I was unable to take on the during working hours, so I just arranged this one. Right. Thank you who are all online today, and we'll close the session.